So on Friday, we were supposed to start a new unit, and this unit is going to be all about exponentials and log functions. So there's two types of exponential functions. There's exponential growth, that means your graph is increasing, or exponential decay, meaning your graph is decreasing. So on these two pages, I want you to find the domain and interval notation of this graph, then find the range, y-intercept, asymptote, and behavior, and then tell me over what interval the function is increasing, decreasing, or staying constant. Okay. Then in example 1, I want you to plug these x values into the equation and then graph them. So there's two examples, and then you're going to do the same thing for exponential decay. So I will start you off with exponential growth. And so we know the domain is our x values, and our x values are from negative infinity to positive infinity. And my range is, all my y values are greater than 0, so 0 to infinity. And then it tells me it touches the y-axis at 1. And then in asymptote, remember my graph is approaching some number but never touches it. And if you notice that all my y values are getting closer to 0 but never touches it, it looks like it touches it, but it's just so close that you can't even see the difference. And then my end behavior, so as x approaches negative infinity, so that's what's happening on the left side of my graph. This line is approaching, or y or f of x is approaching 0, so I'm going to put f of x, or you could put y if you like y better than f of x, is approaching 0. And then what's happening as x approaches positive infinity, my graph is going up or increasing, so then as x approaches infinity, f of x is also approaching infinity. And then where the function is increasing and decreasing or constant, remember when we're reading graphs, we start from the left to the right, and this is always increasing, so I'm going to underline increasing for my entire domain. So from negative infinity to positive infinity, it's increasing. Okay. So now I am going to graph an example of an exponential growth. So my first one is negative 5. So that's 2 to the negative 5th power. And there's two ways you can think of this. So remember, exponents can never be negative. So in order to make it positive, you're just going to take the reciprocal of it. So we put 1 over 2 fifths, which is equal. So 1 over 2 to the 5th power is 1 over 32. So at negative 5, that's about right there. Okay. Then if I plug negative 2 in for my x value, so that's 2 to the negative 2 power. And remember, exponents don't like to be negative, so we're going to take the reciprocal. So 2 squared. So 1 over 2 squared is 1/4, and that's 0.25. So at negative 2, we're getting a little bit higher, but not quite. I'm going to put it right there. And then I have 2 to the negative 1 power, and that's 1 over 2 to the negative 1 power, which is just 1 over 2, or 1/2. That's a 1. And then my next one is 2 to the 0 power, and anything to the 0 power is just going to be 1. And then 2 to the 1st power is 2. 2 squared is 4. So 2 to the 4th power is going to look like that. Then I'm just going to connect my dots. And there's my graph. Okay, so now you're going to do the same thing for the next example. For example 2, and E is just 2.71. You can round it off. And then you're going to do the same thing for exponential decay. So you're going to graph example 3 and then both of those example 3s. And then we're going to talk about transformations of exponential functions to fill in the rest of the chart. So my original function, sorry, I was trying to kind of zoom in and it kind of went a little crazy on me. So my original function is f of x equals b to the x power, and my example is 2 to the x power, so that is my the picture on my graph. And then for transformations, when it shifts up or down, f of x equals going to be b of x plus a. So when it shifts up 5 or shifts down 6, what does that look like? And then it shifts left or right. Reflection over x-axis, y-axis, expand vertically, compressed vertically, expand horizontally, compressed horizontally, and then there's just some questions at the back, so you're just going to tell me, describe the transformation. So does it move up, down, left, right, compressed, expand horizontally or vertically, etc. So I'll do the first transformations, so I'll do when it shifts up or down, and then you're going to do the rest. So when it shifts up, when it shifts up or down, so first we're going to look when it shifts up. So that means here my equation is going to be y equals 2x plus 5. So that means all of these points right here that I have on my graph are going to shift up 5 units. So I'm going to take this point and shift it up 5 units. 1, 2, 3, 4, 5. I'm going to take this point and shift it up 5 units. 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. And then this one, 1, 2, 3, 4, 5. So then it's going to look something kind of like this. And there you go. And then you're just going to do all the rest of for the transformations.